Okay,
Assalamualaikum
Assalamualaikum
warahmatullahi
warahmatullahi
wabarakatuh. My name
wabarakatuh. My
is
name
Muhammad
is
Arif bin
Muhammad
Hashim.
Arif bin Hashim, and
I will
I
start
will
our
start our
assignment 2
assignment
for
2
this
for this
semester for high
semester for high
voltage.
voltage.
This is
This
the
is
content
the
for
content
this
for this
assignment. We
assignment.
have
We have
five type
five
of
type of
content, which
content,
is the
which
first
is
one,
the first one,
introduction,
introduction,
theoretical,
theoretical,
design,
design,
simulation, and
simulation, and
lastly,
lastly,
conclusion.
conclusion.
Okay,
Okay,
for this
for this
assignment, the
assignment,
circuit that we
the
use
circuit
is
that we use
Cockcroft
is
Walton
Cockcroft
voltage
Walton
multiplier
voltage
circuit.
multiplier circuit.
The purpose of
The
this
purpose
circuit
of
is
this
to
circuit
generate
is to
high
generate
DC
high
voltage
DC
from low
voltage
AC
from
input,
low AC input,
and
and
to
to
this is
this
designed
is
for
designed for
particle
particle
accelerator.
accelerator.
The operation
The
of
operation
this
of this
circuit is to
circuit is
utilize a
to
network
utilize
of
a network of
capacitor and
capacitor
diodes,
and diodes,
and
and
the capacitor
the
charge
capacitor
during
charge
one
during
AC
one
half
AC
cycle
half
and
cycle and
discharge
discharge
in series
in series
during the
during
other
the other
cycles.
cycles.
So for
So
the
for the
application, it is
application, it
mainly
is
for
mainly
electronic
for electronic
testing, for
testing, for
example, high
example,
voltage
high
testing.
voltage testing.
And
And
advantage for
advantage
this
for this
Cockcroft Walton
Cockcroft
voltage
Walton voltage
multiplier circuit
multiplier
is
circuit is
it is
it is
efficient to
efficient
convert
to convert
from
from
low AC to
low
high
AC to
DC,
high DC,
and simple
and
but
simple but
effective design,
effective
and
design,
also
and
reliable
also reliable
performance in
performance in
demanding
demanding
environment.
environment.
Okay,
Okay,
for
for
theoretical
theoretical
principle,
principle,
as you can see
as you
from
can
the
see
left
from the
side
left
of
side
the
of the
presentation,
presentation,
the circuit that
the
we use
circuit that we
is
use is
this type of
this
circuit,
type of
and
circuit, and
for the
for the
voltage output,
voltage output,
we can use
we can use
the
the
formula
formula
given, which
given,
is
which
V
is
out
V
equal
out
to
equal
N
to N
multiply by V in.
by V in.
And
And
for
for
finding the ripple
finding the ripple
voltage,
voltage,
we
we
must
must
use I
use
load
I load
divide by
divide by
frequency and
frequency and
capacitance.
capacitance.
Next, I
Next, I
will give
will give
to my
to
friends
my
to
friends
continue
to
the
continue the
presentation.
presentation.
Okay, my name is Mama Amin, and I would like to present about design consideration. Okay, there are two main components that have in this assignment. Okay, for the first one is capacitor. Okay, as you know, its larger capacitance helps move the output voltage. It means that if you use the large capacitor, it will move the process of the project, and it also leading to the more stable of this output. And then for the charge supply, it's educate the capacitance to ensure a steady supply of charge. Okay, it's also to subsequent the stage, preventing voltage drop and maintaining efficient operation. Okay, for the circuit size, of course, if you use the bigger capacitor, it will cost the bigger size to take in physical, and also it will cost the more money. And then for the second component of this project is diode. Okay, as you know, that diode are essential for controlling the direction. Okay, it's control the current flow. We want to prevent the flowing backward, and it is disrupt the charging. Okay, for the energy loss due to forward voltage drop, it across the all diode and contribute to energy losses within the circuit. And for the PIV, which is peak inverse voltage, diodes must have a sufficiently high PIV rating to withstand the maximum reverse voltage. It also can encounter the during operation. Okay, and then I will pass to my friend.
Okay, for the uh, result simulation, okay, the result is use a edge test circuit was simulated with 0.05 microfarad capacitor and with 5 milliampere load and 111 kilowatt AC input. Okay, for the calculation is the voltage average for input is 111 kilowatt for the percentage of ripple, is the ripple voltage is equal to 72 kilowatt, and the total ripple is 144 kilowatt, and the ripple percent is equal to 8.1%. For the voltage drop is equal to 682.67 kilowatt, and the regulation voltage percent is equal to 38.44%. Next slide. Okay, for the stage number is equal to 8 stage, and the result from simulation is for the ripple voltage is equal to 15.15 kilowatt, and the simulation result for the voltage drop is equal to 322.4 kilowatt. Next slide. Yes, this is the circuit for 8 stage Cockcroft-Walton voltage multiplier with 16 capacitor and 16 diode. Okay, next slide. This is the result for the simulation ripple voltage of Cockcroft-Walton voltage multiplier circuit. Okay, for the peak value for the maximum voltage is 1.4536 megawatt, and for the lower peak is 1.4233 megawatt. This the graph for the simulation. This is the graph ripple. When we zoom, we can see the ripple of the graph. Okay, next slide. Next. Okay, this is the graph when we not zoom the ripple. Okay, for the next slide is I will pass to my friend Gregory.
Okay, thank you, Kelvin. I will present about the comparison, the result that we have taken. So for the ripple voltage, the theoretical ripple voltage per stage we get 72 kilovolt, but when we simulate the ripple voltage we get 15.15 kilovolt. So as we know, the ripple voltage in the Cockcroft-Walton voltage multiplier circuit demonstrate a significant difference between theoretical and simulated value. So for the voltage drop, theoretical voltage drop, we calculate, we get 322.4 kilovolt, and the simulated voltage drop 682.67 kilovolt. So the voltage drop in a Cockcroft-Walton voltage multiplier is a significant difference between theoretical and simulated values. Right, next slide. Okay, for the conclusion, to conclude our assignment, the Cockcroft-Walton voltage multiplier is designed by arrange the capacitor and diode in multiple stages to make it ideal for high voltage and low current application, which it convert a low AC voltage to the high DC voltage. So the study revealed significant unexpected difference between theoretical and simulated result, with the theoretical ripple voltage at 72 kilovolt per stages compared to the simulated 15.15 kilovolt, and the theoretical voltage drop at 322.4 kilovolt versus simulated 682.67 kilovolt. So these different highlight real-world challenges such as diode forward voltage drop, leakage current, and capacitor limitation. So to optimize component quality and balanced stage design are essential to bridge the gap between the theory and practice to ensure the stable and efficient performance. Okay, thank you.